Okay, now we're going to discuss if we have to solve for more than one missing angle. Um, so here's this triangle again. Pay attention to how it's labeled because they're not always labeled the same. And again, across from C will be big C, across from big B will be big B, across from A will be big A. So if you're looking for a missing angle, you have to use new functions. And because I'm teaching our class out of order of the textbook, it's going to feel a little like, what? I guess I'm just going to accept this. And that's because I just really believe in teaching it this way. And we're going to get more into these functions in Unit 6. So you kind of accept the definition, similar to sine, cosine, and tangent. So you use those functions to find missing side lengths. And to find missing angles, you use the inverse function. So the inverse function, your input is the ratio of the side lengths. If you remember from 111, inverse functions, you swap the domain and range, right? So with sine, remember, sine of theta, the definition is opposite over hypotenuse. So if I'm doing the inverse, notice how my input became my output and my output became my input. Okay, so you use these functions, they're just a brand new function, all right, to find missing angles. So you either use the inverse sine, inverse cosine, or inverse tangent. You can use inverse secant and cosecant and cotangent, but again, they're not that useful when you're calculating on a calculator, so we're just going to stick with inverse sine, inverse cosine, inverse tangent. Another way you might hear me refer to this is arc sine, arc cosine, arc tangent. Just another way to say inverse for sine and cosine and tangent. All right, so if I'm looking at this triangle, it says solve the triangle. We have A is 5 and B is 3. So A is 5 and B is 3. Well, right off the bat, I can solve for C because it's a right triangle. Make sure it has to be a right triangle in order to use Pythagorean theorem. So I can do 5 squared plus 3 squared equals C squared. So I get 25 plus 9. And then I get 34. I take the square root, so I just get the square root of 34. Let's leave it like that. Sometimes you can simplify it, and that will happen later this term. But right now, 34 doesn't break up to anything. It's 17 times 2, so I can't, there's no perfect square roots in there. So I have the last missing side length, and now I need to find the angles. Well, I clearly know what C is, so I don't need to figure that one out. And I'm going to hang out at B. That was just my choice. I want to solve for B first. So if I'm standing at B, always use the side lengths that are given to you just in case you messed up on the one side length you found. So if you're standing at B, what is 5 to you? Adjacent. And what is 3 to you? Opposite. Which one deals with adjacent and opposite? So once again, I'm going to do so, ka, toa. All right, so it's tangent. But because I'm finding an angle, I'm using this new function. So inverse tangent of toa, so it's opposite over adjacent. And I'm going to go ahead and bring up my desmos. And if you look here, make sure you're in degrees still. I don't see that inverse function, so if I go to function, then you'll see it. And so inverse tangent of, and then I'm going to go back to main, 3 divided by 5. And let's go ahead, erase that straight equal sign, equals approximately 30 point, looks like it'll be 96. Now this is really important. Make sure you put degrees. There's another unit out there. We're going to learn this term, and we want to make sure we're clear with our units. So this is degrees. All right. And again, pay attention to my math lab and what they want you to round to. Now, I'm going to get out. I'm not going to stand here anymore. No more, no more. Now I need to solve for A. Oh, let me actually be careful. I solved for B here, so make sure you state what angle that was. So now I'm going to hang out at A, because that's what I need to solve for. So A equals, again, I'm only going to use the 5 and 3. So 5 is opposite while 3 is adjacent. So opposite and adjacent. Again, I'm using the inverse of tangent, but now the ratio is 5 over 3. So go ahead, and I'm going to go to function, arc tangent or inverse tangent, back to main, 5 divided by 3. And I get approximately 59.04 degrees. And hopefully, when I add these 2 degrees together, I will get another 90 degrees, because I have to, my triangle always has to be 180 degrees. So that's a good way to check. Okay, so let's try 2 more. It says with group, but unfortunately we don't have that option. So here I'm looking for angle X and angle Y. Just depends on what you want to solve for first. So I'm going to choose to stand at X. Realize this is your hypotenuse because it's across from the right angle. So 12 is adjacent while 4 is opposite. So again, I'm looking for an angle, so that's my red flag that I'm going to use the inverse function of opposite over adjacent. And again, I should be very clear that this is X. So go ahead and get out of here. Inverse tangent of 4 divided by 12. And I get 18.44 degrees. Now, hang out at Y. Let me go ahead and get rid of all that. Now, if I'm standing at Y, well, what's opposite me, 12, and what's adjacent is 4. So it's very similar to the previous problem, arc tangent of, but now my ratio is 12 to 4. So I'm going to get out of here. Inverse tangent of 12 divided by, 12 divided by 4. And I get approximately 71.57 degrees, or it should be degrees. Okay, so the next one, let's just make sure it's sinking in. Again, you know you're clearly looking for angles. I don't have to solve the triangle. When it says solve the triangle, you have to solve for everything unknown, but this is just saying solve for X and Y. All right, I'm going to stand at X first. I'm clearly looking for an angle, so that means I'm going to use the inverse function. 4 is adjacent to me, while 6 is the hypotenuse. So adjacent and hypotenuse, that is cosine. Inverse, and that's ka, so that's adjacent over hypotenuse. And let's go ahead and get this back up. And this is going to be inverse cosine of 4 divided by 6. 48.19 degrees. Okay. I'm going to go ahead and get rid of this. Or maybe we'll just bring it over here. Okay, so it'll be 48.19 degrees. All right, now I got to solve for y. Hang out at the y. 4 now is opposite that angle, and I'm still given the hypotenuse. So opposite and hypotenuse, that is inverse sine. Opposite over inverse, or sorry, opposite over hypotenuse. So I got caught up because I was like, wait, the ratio is the same, but look, I'm using different functions. So inverse sine of 4 divided by 6, and I get 41.81 degrees.